get started. Are you guys excited for it? Are you guys excited for it? Cool. She has
The top one.
okay. She has already give introduction about us, right? Do you need some more introduction about us? Something non-technical. So we like I like trekking, he likes to play video games and all, okay? Like apart from data engineering, this is something different about us. Now let's get started with our with our main topic, right? So we actually build a very interesting yet challenging, we have actually solved a very interesting yet challenging business use case for our customers. That is nothing but creating a unified customer platform, our platform for our customers. So in that, we are having a very comprehensive view of the customers. Let's say we are actually trying to solve, there are terabytes of data coming from different platforms. The platforms are like very different platforms, like real-time processing, online, offline sales are there, or website data is there, right? Or social media data is there, right? So from that, we are trying to create a meaningful insights for our customers using Spark as a core and the accelerator which we have built in MathCo. So why this is needed, right? So this actually is getting used by our marketing and advertisement team, right? They are actually using this data, like the customer related data, for getting different profits, right? Targeted marketing they have to do, or let's say they have to target some profiles also. Then they need to create a good customer engagement platform for their customers, right? So that is the end objective here, and let's stick to that. Those are our objective, targeted audiences, right? So marketing and advertisement teams are our targeted audience for this session, and let's stick to that for today. Now the next is our customer is actually depends on the C360 degree view of the all the information, right? So we need to essentially understand that first. As I said, data is coming from different sources, different platforms, in different way also. Like we'll be having structured data, unstructured data, real-time data, then batch process data, right? That we need to understand, essentially we need to do the unification on this data, right? Now unification means what exactly we are trying to do. So the first thing is unifying the customer data. Now this customer data is basically kind of transaction related data which customer meets, right? Online, offline, anything. Then we'll be having interaction related data. Now customer made interactions. I like to do shopping through some websites, or I used to do shopping from some stores, right? So different interactions with our clients. Then parallelly, there are profile related data that we need to unify. Next is let's say we got the data. Now the next is we need to create a relation between that data, right? And that is nothing but unifying all the customer data analytics, right? Well, let's say we have a historical data or we have a current data, and we need to do the aggregation between data. Let's say then correlation between the data, and we need to set up some contextualization between the data. Now we got the data, we got the relation between data. Will actually help business to upsell, right? Or do the good ROI or cross sell will happen, right? So next is to get all these things. What kind of challenges customer face, right? Any guesses? Obviously there is a huge list we have listed over here, but out of that, just for simplicity today, we want to focus on some key aspects or the key challenges which we observed while working with multiple customers. So the first one is fragmented data. So fragmented data actually impacts into the inaccurate customer segmentation and targeting, right? Now the next is when we are working with different data, right? And it's segregated into different it's getting segregated and handled by different teams. So let's say if customer raises a request to delete their information, that is a customer deletion, right? So, and if we are not able to delete that information throughout the customer journey, then it will be the risk of non-compliance, right? And that is like very major or crucial one, right? That we need to handle, because customer data is not normal data. It's a PI related data, personal information, right? That we can't directly, like, it will be a non-compliance for us. So let's say in Europe region, they call it as GDPR. Then in US region, they call it as CCPA, right? So impact is like risk of non-compliance and due to fragmented user view. So the next is like inaccurate attribution also we used to do, right? So it's very difficult because of inaccurate attribution. Data is coming from different channel, and throughout the journey of the customer, it's difficult to maintain also, and it will impact into the poor decision making, right? So these are like different challenges. Others are, you already know, right? Data silos and all. So the next is like on top of these challenges, what kind of outcomes or the criticality of customer data we faces, like, or we achieve. So the first is 360-degree view. Obviously, we need to identify, we need to unify our customer information, and that will help us to target our audience, target our peoples, and parallelly it will it will help us to upsell more, right? We'll create some ROI on top of that. The next is like we have to get some personalized marketing experiences. So higher conversion rate we can achieve because of that. Let's say like there are multiple, right? Obviously we also do, like, first we go on some social media platform. If we like something, we add that product to the cart, right? But then if we maintain the, like, let's say if someone selected some product, and on some other platform, if they get the advertisement for that, it will increase the interest for that, and that customer interest will get converted into the conversion. Like, it will get converted. That person will purchase something from that card, right? So that is a personalized marketing experience. The next is like complete behavioral history. Obviously, like history data, current data we have, right? And we need to do the segmentation between historical data and the current data. So that is one. Next is single source of truth. Single source of truth is obviously important. It's because, like, again, data is coming from different sources in different format. But if we don't have that data unified into one location, then it will be like little risky for the non-compliance thing. So single source of truth at one place is important to mitigate the risk of non-compliance. Now the next slide is basically we discussed about what kind of data we got, right? Then why it's critical to create a C360-degree view, right? And the third is like what kind of challenges you faced, right, to get these things. Now we want to deep dive a little more how we are actually solving this issue, right? So it's a basically modern customer data platform, right? That is in some other words, CDP we call it, right? So what is CDP? So CDP is nothing but like centralized data management, or we'll be having unified customer profiles over there on that platform. Then real-time data processing we do, or let's say compliance data governance also we do. Now, out of all this point, I want to just discuss more about the data integrations. Now, data integrations is like, what we observe is like for one of our customers, they have more than 40 plus integrations, like more than 40 plus sources coming from different platforms with different type of data, right? And that like we need to process properly. Otherwise, again, poor decision making, all those things happen. So that is nothing but data integration. So now, like, I would like to hand over the things to our senior architect, because the next area is like, he is very perfect at, and I might be sometimes faulty. So I'll just give over to you, sir. Thanks, everyone.
Thank you, Resma. So at this point, we have seen what is a customer data platform, how does it solve some of the problem, but let's deep dive into a little bit of technical things of that, right? How does a customer data platform looks like from technical perspective? So you can see that this is a technical representation of the architecture of customer data platform built on top of MathCo. You can see there's a lot of services, a lot of tools that is interacting with each other. It's complex. As an architect who works in these things daily, I love this type of architecture. I really love this complexity. But for this stuff, we will not be able to deep dive into that. So let's deep dive into a very simplistic view of this. So this is one of the view of a CDP platform architecture, which is not different than any of the data platform. It doesn't have to be customer data platform to look like this. But here, some of the differences are there from a normal data platform, which makes it a customer data platform. Right? A couple of those differences are in processing and governance and storage. Right? So we'll start explaining it a little bit, spend some time in this thing. So when we build a platform, we'll start with ingestion, because we have to get the data, we have to onboard all the sources and everything. Right? So we have to build our ingestion system in such a way that it can bring anything and everything that has been thrown through this platform. So it can bring stream, it can bring batch, it can bring binary, anything, even micro batches, efficiently. Then the problem comes to storage. So how exactly we have to design a storage solution. So when we build on cloud, it's simple. Anyone can say that, hey, for cloud, we have cloud storage, we can take ADLS, we can take DCS, anything. But that's not the solution. The solution is how do we structure our data? How do we store our data? So there are two ways. The first layer of is like what table format that we use, what file format that we use in terms of formats. Then the second thing is what is our data model? We are building a data platform and building a data platform on top of cloud. So I have to choose our data model, file format or storage format. Very intelligent. Louder? Thank you. Is it audible now? Great. Now after storage, we'll come to processing. You can see that we have two layers of processing. One is standard data cleaning and transformation. When it comes to customer, the cleaning part will be a little bit different because we will be handling PII. And cleaning addresses, names, all the PII information will be a little bit different than a generic data platform. And then another set of processing is there where we'll do IR, identity resolution, we'll do profile aggregation, customer enrichment, all those stuff. Very specific to customers. Then another important part of any CDP is the security governance. That's where comes the bottom layer, where the governance and cataloging is there. After all the platform has been built, we build a platform for consumption. So when we build a platform for consumption, we choose three types of things into that. One is analytics consumption. Anyone can go ahead, do some ad hoc analysis, create dashboards, do some predictive analysis, all those type of stuff. Another one is collaboration, where we'll be sharing the data through data APIs. Give an example, Databricks has something known as Delta Share. That's a data API. We can build our own data API. Then there is activation. When we build a platform, the ROI has to be measured. Someone has to take the data, analytics data, and do some work. That's the activation for marketing, advertising, or any other solution. Right? So this is a customer data platform architecture in overview. So while building this thing, we'll come up with some of the challenges. So when we say that we are building a data platform, we don't build a data platform for 1 GB, 10 GB, or at max 1 terabyte of data. We build a data platform for long term with huge amount of data. When I say huge, it goes till petabytes. That's how we work. So the challenges are pretty simple here in a data platform, right? Huge amount of data is coming. We have to send the data to the business in very fast manner. So timeliness is there. Correctness is there. We have to keep the data in the correct way, make it available for everyone to use. Processing. So let's say it's a customer data platform. What's the processing? It's customer linking, record linkage. We will link data from different systems into one customer, or maybe X number of customers. How do we link so many data points? In a terabyte, there are billions of records. How do we link so many data points into, let's say, 350 million, just an example that has been given, but maybe 300, 500 million customers. It's too difficult to do. And another thing, while we solve for any type of data platform, is the unique key and global key assigned to that. Because nowadays everyone is working on distributed system, like maybe Spark, Flink and everything, and there is a challenge. how can we make it correct and get a key. Okay? So there are all these points I've covered, and these are the main challenges. There are a lot of other challenges. If someone says how the security, networking, what we are not doing. Now coming to solving those issues, we have spoken about from starting, like this is the talk where we'll be saying how Spark solves the issue. So this is where we'll deep dive, right? How Spark solves the data platform issues, just we discussed before. Right? So let's start with a basic one, right? Huge amount of data. So when we talk about huge amount of data, first the first problem that comes to our mind: how to process the data, right? How to link the data, how to get the data into a system where they can effectively process and fastly available, right? That's where Spark comes. So when we process huge amount of data, it's evident that we will face some failures. It's normal, everyone faces that. When the failure happens, the challenge that we got, should we process the full data? Should we process only that task? Or should we process that micro batch? That's where Spark helps. Because we can design system with Spark which only process the minimal failure segment of the data. So it makes things much faster, we don't have to reprocess everything. Second thing is, like, we get all the sources at one place. Now some of the sources might not be based on customers, some of the sources might be based on products. We can just do a pass through and make it available for the business to use. But to do that, we cannot wait for our batch process to run. We have to make it real time. Spark has a unified API both for batch and real time, just the storage has to support. Second one is huge amount of data. We do aggregate, we do join, issue with suffer, right? And it's an issue with every type of distributed system that is available. Spark is no different than that, but the latest version of Spark really tackles it very well with a new version of suffer management. And when we speak about Spark, we also have to look into some of the already available platforms like Databricks or the cloud-specific vendors, where the suffer management has been done differently than open source, and it makes the life of a data engine very easy. Then comes to linkage. So when we talk about linking data, doing everything, one thing that comes to our mind: it's a graph, it's a tree, maybe it's a heap, however it is, right? And how to solve it. And Spark has a graph API. Most of the times we don't talk about, we don't use it because it's like a little bit hard to use, less documentation is there, obviously. But Spark graph API is very, very good. Things like identity resolution, things like linkage, customer linkage, deduplication, all those things can be handled with Spark graph APIs pretty efficiently. Some of the time it can be non-deterministic while using, but there are tricks that we can apply and make it deterministic. And then there is memory management. I hope everybody here and some type of data engineering knows about how well Spark manages. Now come to, we're speaking about Spark, like why exactly, right? Why Spark? So Spark can integrate with different systems, and this slide is about that, but it's not about systems only. Everyone knows that Spark is an open source tool. It's available on cloud, it's available on different types of vendor platform. It can integrate with different types of storage, it can integrate with different types of other tools and services, but where Spark excel is like, it can integrate with other type of processing system. Take an example of Flink. Anybody uses Flink, Spark can directly integrate with Flink. Take an example of a data scientist who is working on pandas. Spark has a lot of coverage on pandas API, where it can be directly integrated. And nowadays even Pyro is available, right? So the integration is not on top of tools, services, or storage. It's on top of other frameworks, other operations. Even vendors like Databricks make it so easy, like we can integrate systems like Tableau who can read the data out of a Spark data frame easily. Okay. So that's about integrating systems of Spark. Now coming to another challenge of unique key. So this is a different segment that we have to, because unique key is a challenge that we face in day-to-day life when working with Spark. So what's a unique key? Let's say we are working on customer data. We have lots of transactions, we have millions of transactions, and in a year maybe multi-billion transactions that we have, and we have to assign unique keys. So how to do it? So either we can use a transactional system, generate a unique key, it will not possible, but it will make our life difficult because it's a transactional system, very small, low resource and everything, but in Spark we can do it, depends on our requirement. So I'll just take a couple of examples here. Let's say a requirement is like we'll generate a unique key, but there is no other requirement. It can be integer or alphanumeric. Best way, go to alphanumeric. Don't have to research a lot, don't have to persist, don't have to take the max value, all those things you don't have to. Take a UID function that is available, use that, dump the data, you have the key available every time. Unless the requirement is integer, you have to do again and again, then you have to think of, do you really have to generate a sequence or do you have to generate only an integer? If it's an integer value, monotrivially increasing ID is there. The sequence, zip with index is there. But each and everything has its own calculates, right? So it depends on our use case, how fast our requirement, how fast do we want the data, all those things will decide this type of functions. So unique is the biggest problem in Spark, always being there, not in Spark, any type of distributed system. So it's a problem of distributed system, nothing inside Spark. But Spark really provides some of the functions to mitigate that. And lastly, I want to cover one is custom ID generation. So there is a requirement that is not covered in any of the functions. The requirement is like we have to generate an alphanumeric value. It is fast to generate, we'll write it always unique, and it has to be sortable. So we should be able to sort it. So what should we use? We don't have any function in Spark. So we have to use something like a lexicographically sorted unique ID. So there is a new white paper that is there, even Python has an implementation of it, it's known as UID7, we can use it. Or you can use something like a snowflake ID. Big research and developed by Twitter, we can use it. Currently known as Excel. Now coming to storage, right? We spoke about Spark a lot, right? But a processing system doesn't work alone. I have to store the data somewhere, right? That's why we have to choose a storage. So there are different types of storage. So there's a cloud storage layer. On top of that is a table format storage layer. Below that, again, in between that there is file formats, right? You have to choose which storage layer. We have to go, sometimes you have to choose why. So here we have shown that how Spark and Delta works data, but it can be anything, not only Delta. It can be an Apache 2D, it can be Iceberg, anything, a different file format or a table format, right? So when we choose Spark with a specific storage that it works better, what are the benefits that we get, right? Let's take an example of Delta that we have given. So Delta provides us a way to do AC transactions. Now in the CD platform, someone will ask why we need AC transactions. It's just like a data warehousing or a lakehouse system. We really don't need it, we can handle it. But keeping it makes our life much easier so that we don't have to reprocess huge amount of data again and again. We can only reprocess point-in-time data that is get affected. Then there is another benefit that we get is a batch and stream API. Spark supports batch and stream. But now the storage has to support because it has to hand over the data to the processing system. That's where again Delta shines. It provides it. It's not only Delta, again I'm reiterating, it's there in other table format, but Delta implements it very well. It's unified API. Then come to another one is the biggest problem of distributed data processing is the small file processing. So let's say we have 100 GB of data and the number of files that is there is 500 and we have 200 GB of data, number of files that is there is 10. There is a big chance that those 200 GB of data can be processed much faster and efficiently than the 100 GB of data. It depends on a lot of factors. Just giving an example, and it's possible to showcase that. And small file processing problem is there in Spark from starting, in any of the distributed system from starting, and it can be mitigated by the processing system. It can be, but extra processing has to be done. So that if we use some storage like a Delta or SS table storage structure, it mitigates it by default. So when we write into Delta, read from Delta, it just makes it more faster. Now we have seen a lot of details, technical details about why Spark, how the things have to be built. So that's the key learning for us from all those slides. So when using Spark, we should always use specific functions that is available for requirement. Also, when you using nested data structure or the data nested data types within Spark, we should use higher order function. I've seen that, and we have seen that most of the times we are not using higher order function, rather than we like to explore the tables or flatten the tables and do some UVMs. It's not the best. Second thing is like, don't treat all the data platforms in cloud, in Spark, or the data lake as a transactional system. While it can do all type of transactions, but it can't do in efficient level. The more I/O will do, the more slower will be, the more difficult it is to get. Don't treat it as. The last thing is use Spark efficiently both for streaming and batch processing. With all the key learnings in MathCo, we have built our own accelerator. You can see that this is our own accelerator, which helps all our clients to solve their CDP problem. Right? So it's an accelerator, you can see that's a 3-layer accelerator. We have core, then access layer for developers like us. Then there is business layer for the business, and it can integrate with both batch and stream pipeline. So if we see the accelerator, the way it has been built, let's start from top, the business layer. It's already built into the accelerator, means when this accelerator is plugged into your customer data, it cleans the data, it standardizes the data, it does eye resolution, profile aggregation, all those stuff, and provides a singular customer view. That's the customer 360 CDM. The CDM is already baked in, the data will be available, so the outbound is enabled to use that. Then it can also integrate to MathCo's own DQ framework. Once we integrate, you can see Watchtower. If we don't integrate, it has its own DQ rules to be processed and edited. Then there are some of the pre-built dashboards and view that can be used by the business to do some decision making, and the templates are available also. Now coming to what's the benefit of MathCo's accelerator. So there are so many points, but I want to just focus a couple of them. That is, one is data privacy and compliance. Because we go to the previous one, we can see that we have something like data anonymization bottom left column, right? So what that makes us is like it keeps the user data separate than the analyzed data, so that the data privacy and compliance has been taken care of, that it has access to it, has access to that. Also, it makes the outbound systems enable to fetch the data out of the system. It has APIs, it has SDK, we can use it, we can integrate with most of the third-party tools. When I say most of the third-party tools, the ones that we have already tested. And it can also take input from other third-party tools and process the data. So that's all for now. This is a 30-minute talk. We have planned a lot, but we could not cover everything. So, any questions?
Hi, I have one question. You mentioned that work already is Spark-based system to avoid upserts, right? Upserts and deletes. Now, sometimes what we do is that we are building this enterprise analytics platforms where we have to bring in data from transactional systems like AD or R or something. Now, those transactional systems are doing the upserts and deletes at their end, and we have to reflect that in our data platform, right? And we are doing this in database using Terabytes. So, do you have any any best practices or any standard approach that you do to handle those in a better way? Because yes, we do face problem with handling those upserts and deletes at the analytics platform. And so, any best practices or approaches that you have?
Yeah, to comment that, I have to know a little bit more about the system, but in general, if I comment, yes, we should avoid it, but there are certain times that we cannot avoid. But let's say we are using it, how to make it better is like vendor specific implementation of Spark like database. You do offset, enable photon, it makes, like it brings down the offset time to nearly half, what we have seen in some of the cases. Most of the cases it's like bring down to 20-30%, something like that. It's also in the documentation. And also for offsets and deletes, wherever we want a single view, let's do it a offset. But wherever we can keep off log, let's do a insert always, append only. And later when we need it, take the latest data, only pick it. So you can maintain a CD table for that, or you can maintain an append only table with a timestamp and take the latest one. But it depends on what's the use case. The use case is like only once or twice that we are using, maybe in a day. So append only, then carve it out and